Burr Arch Truss Bridge. This is in Crum Creek Bridge, you guys. You don't Bridge Hunter. It's got a different name to it also. Not sure of the year. There's a couple of versions of that year. It's over 100 years old. 1920, I believe, something like that. Another one. Well, Burr Arch. Burr is the engineer that came up with this design. It's confusing to some people. Even the computer models is I didn't put the link on it down in the description. I meant to show you guys a link on the description. If you look up Burr Arch Truss Bridges, you'll see that this computer models. Well, the Burr Arch guy, the engineer, he believed that the arch was the mainstay of this bridge, but the computer models, as a lot of people will say, is the truss system is. We're gonna even go down into the water. So this bridge, you'll be able to see it. Get like a closer. What we're looking at here. So it's an interesting structure. And I got rain going on outside here, so I've got to be leery of that a little bit. There's the archway. You can see the arch. And it reminds you of a Pratt system, if you will, a compressive tension member. This is the last compressive member. This is, of course, a load-bearing, roof load-bearing, but this would pretty much be zero force, this one and this one. This is also a compressive member for the roof load. So as we look at this little lady, take note of these bolts, etc., and imagine that if you could, what the implications of the bolts are. It ties the truss system together, the archway together. So I've really evaluated this a lot already. I'm just talking, but I've gone over this bridge before I'm talking to you now. So feel free. I think the chat's working. You can ask me anything. As we scroll over here, let me move over. As you can see, the bridge is not sound, so they stopped it for people to walk on it. But take a note at one of the compressive members how they notched it. I know it might be grainy. It's notched. It's sitting on there. It's the compressive member itself. Off the camera is it transfers the load. Even though it's notched, once you compress these together with that bolt on the outside, this bolt, help me out, this bolt right here. Let me zoom out. It acts as one. It becomes a one system. And I'll show you. I guess I should jump down there. This is more clear for you. Can you see the top now? You can see the truss system, how you would go up, over, and down again. This is the half of the bridge, if you will. How you can see the Pratt system is in there. Now the Burr, the engineer, his intent, as everyone thinks, is that he wanted to transfer all the loads. Basically, the arch would handle all the work. And this would be secondary, the Pratt. Well, you can call it Pratt, but his system. Now let's scoot on up. I'm going to take a couple of measurements with my laser. I think online the best you can find is 81 feet in length. I'll do that from the underside. Hold on, getting my laser out. But I'll do a little quick shot up here too. Let's see if I can come up with something to peg with my laser. Okay, I've got something nice down the other end of the peg. I've come up with 79 feet, 9 inches. 79 feet, 9 inches. I think they're calling this 81. I pegged my lasers down there now. Let me do it again. Check my laser for level. And I'm pegging this. Oh, no, it's an error. Sorry. Taking a secondary measurement. Give me a second here on the length of this. Come on, baby. Give me a second to pick it off again. It's kind of hard to see 80 feet and you're looking for a red dot. It's not actually hard. It's just a matter of... There we go. Oh, great. It's taking a secondary reading. Give me a second. Let me clear this. This is a starting over. I got 79.9 a second ago, but I take 2 readings. And blew that reading. And blew that reading. It's got to be able to read back. 79.97. So 79 feet 7 inches. And I got 79.9 a moment ago. Let's peg off the width of it. That one I can just reach in there and peg off the wall. So the width I'm coming up at 17 feet wide. So I might have to put that on Bridge Hunter for people to be able to see it. 17.2, 5.6. You see the first reading was 16.7. So I'll get another reading, get a little more affirmation on that. So the last one is 17.2, and we'll shoot this one. Checking my level. Yeah, 17.1. So I'm going to peg it at 17.1 and 2. You guys can pick the difference. Well, you can pick the difference. 17. What's an inch amongst friends? So let's shoot on there. So we've got 9, some change. Take you underneath, and let's try to look at that. Which one is it? Is it the arch? Is the arch holding this thing together, or is it the truss system together? Now, if you Google real quick the Burr system, you'll understand what I'm driving at. And and you guys, I'll give you a second before I give it to you. Oh, great. I didn't turn the light on the camera. Hopefully it's not too dark. But this is the underside of the structure. And while I'm here, let's just talk about the backside. So this is your abutment. And you can see that was a repair that took place at one point on one side of the structure and notched out and added. If you look at the other side, that's existing. I think it's going to be too dark if I get over there to show you the bolt that they use. I'll just show you two out in the water. Let me do this. Let's do abutment to abutment under here, laser wise. And let's get a reading on that. So abutment to, give me a second. Clearing my stats here. Okay. Checking the level on this laser. Okay. 59 feet from abutment to abutment. 59 feet 1 inch. And just you don't have to worry about scouring on this one, deteriorating the bridge. The water appears to stay down here with some overlap onto this little bit of rip wrap, we'll call it. Sorry, I gotta zoom out. Now back to this. You can see there was another repair here. Well, let's figure it out. Which one do you guys think it is? Is it a truss? Is it the arch that does this bridge up, or is it a combination of both? I'd say it's a combination of both, but so the arch is, let me go a little bit. The arch goes from here, as you can see, the one part of the arch going into the abutment, coming up into the structure, see now, and back down, and it comes down over here. So now you can visualize that. What we have here, we have railroad tracks, I-beams rather, correction, not railroad tracks, that was my first impression. They're I-beams acting as another girder system for this flooring system. Let me zoom out. As I touch my computer, my phone, it's doing its own thing. Here are your floor beams. Come on, it's doing, every time I touch the screen, it zooms in. That's brilliant. I'm trying to make sure I'm zoomed out. Let me leave my laser here for a second. And because I'm going to step down in the water. If I'm going to fall in the water, I don't want to trash my laser. So we'll step down in this water here. It's only 2 foot deep, as deep as. I'm going to have a little fun with you guys. Now, you guys love bridges. You like a little education. Look at this. What do you gather? The answer's there in front of you. The answer's there in front of you. Looking at this, these are the members that came through the archway. Remember, if you saw up top, the arch is here. It's dual. Great. Let me just tap it for focus. It's a dual bottom chord, 2 chords to make this member. Now they have these going through. These are I'll just cut to the chase a little bit for you. That's a bar, right? That's a bar. That's a bar. Now would you put that under compression, or bars better in tension? Bars are better in tension. So there's going to be tension. Let's see if we can get some consistency. Well, if that's tension, oh, compression. Just thinking out loud now. Tension. Oh yeah, that works out. That makes working out that way. Huh. Every other one. Huh. There it is. Interesting. Now let's confirm that if it's tension or not. Well, if it's under compression, it's a bar. It would separate from there. As the load was on it, it would be separate. And so I look at every single one and find one that's separated. And I cannot. They all seem to be compressed, meaning they're under tension, pulling upwards. And we look at it and we say this thing was original. Well, let's look for some compressive marks around the outside edge. How much load it was having. I don't see any real issue going on there. I don't see any compressing timbers, crushing members around here. I don't see it. I don't see it here either. I don't see it on any of these that I looked at. Sorry, I'm walking the water, as you guys can see. I don't see it here. I don't see it here. So now we start thinking about, these look like original plates and steel. And start thinking about it, if this was the original design for taking loads, and you think of the truss system taking it, not the arch system of this bridge, then you would say, well, shouldn't we, over all these years, 100 years, have seen some type of indentation in this material, this wood, some compression, some. I don't find it on. And where would it most likely show? Almost took a dive. It would most likely show in the middle, right? The loads are greatest. Hold on, guys. I gotta half watch my step. So we don't see it compressing here. So I would say that the original designer who said Burr, that said the arch is primary, I'd lean towards primary. The arch system, the truss system is secondary, no matter what the computer models say. The computer models say that this system, the truss system is primary and the arch is secondary. Well, how come we've got 100 years of experience of experienced bridge, and we find no tension, we find nothing. How you doing, Blindy? That thing is sweet. Thank you. So it's walking in the water, right? So back to this. This will be the compressive member. Now take note how thin the material is on the outside of this guy. It's so thin. All these years, if it's so thin and this load's on here, how come it just didn't split? Well, because this bolt makes the whole deal, compresses it together, pulls it together, and now it does look like it's got a gap between it, doesn't it? And that would further affirm that the arch system is taking care of everything. That looks like a gap between there. Can I zoom it? Sure can. That would further affirm that, wow, it's a nice put together structure. Oh, it's even more than I thought. It's dadoed. It's let in, if you will. So it's really inside there. That's interesting. That could change into tension then. Since it's let in, it could change its forces going compressive and tension. Nice. Well, the bolt would have served that purpose. This could explain why that's loose and I don't see anything going on. There's knots, there's beautiful let-in knots. Here's the outside of it. It's just clapboard, old siding, not old siding, it's siding. And there's your bolt. I can't show it. Sorry, shooting into the light. Let's come over here and see that sister one. You look at the sister one. And remember, if these are under compression, I'm going to also look to see if I can find some movement around that. Let me see if I can get it clear. Come on, baby. I'll zoom out a bit. Again, zoom out a bit. I'm looking for movement around here at all. None. So the bolt is just holding these guys together. It's doing its job holding this together as, zooming out, as compression. So it makes this one again, this section where it's so thinly notched. Where it's so thinly notched right here. Once you bolt this in, close it back up, you now got the material acting as a solid material again, not as a material that's been notched the hell out of. With that said, look down here, I'm coming down. Near the end here, we've got a repair. We're looking at the ground as I'm holding the camera up. So here's your repair. And if it's a truss system, then this would be the tension side of it, the bottom side of it, pretty much. This would be acting in tension, and I'm looking for like a tension issues and how it would be moving and it would create like a more of a shearing. It would be counter to your member here in a thought. Now you can also see what you can't see there. It's bolted, through bolted floor beams. These are the floor beams, and they through bolted there. So there's the bolt going through your compressive member, if you will, and coming through the other side and securing the floor beams. There's the backside washer. Plate. I said washer. I'm going to take some liberties here. And this would be your tension bar going all the way up. And if it was in compression, I would hope to find some bending or flexing in these bars. I looked at the bars. I see it short of this bent bar down here, which I have no idea how that happened, obviously. And then we have this repair again. The other side of this plate, which is a funky repair that seems to have worked. It's just some half-inch galvanized plate with some galvanized bolts running through it. Same thing with here. Which is the plate's probably only 5 inches in height. Zooming out and going back across. Now we got a cross bracing to help hold this all together. I guess I'm loose now. We got hey William. I wonder which they did go first, the truss or the arch. You know, not until it's complete. I thought of that, William, and I figured they must have just sandbagged it of some type, you know, back then, or they had stone access. So maybe they made a little stone access. This water, I don't know what it looked like back then, but you know, the banks, you figure nobody's messed with these banks, no development. Bridge Burr, yes sir, local. So you figure you would, you know, back if you had a building, you could see how long the members are, which is pretty significant. These members, I didn't find a notch of any type, so these members appear to be full length, as you can see. I look for it on each end. Great, I got a stone in my shoe. That's just awesome. That's the existing bridge, the real roadway bridge next to it. And I think I talked about this already, saying that this is the repair. You can see the brick down there. But there's the original member above it, and then there's a repair. So it appears that the repair, I like playing with words, right? On each side has an issue on this one member only. Oh, I'm sorry, I guess that one too. The other side didn't have that. It's the inner member. Oh, I think I saw that on the other one too. These plates. So giving that some new thought, this was all rotted out. I forgot I just noticed that. Oh, before I started the video, I noted I had to talk about that. I think I hear people above me. I do hear people above me. I do hear people above me. So this plate has a flex in it right there. People are above me. Probably freak them out here and somebody walking on into the water. And again, a gap there. So that's being pushed down and separating. It'd be nice if they could just put some support on this damn thing. I hope you guys can hear me. I'm whispering not to freak the people out. Now we're closer on this. Oh, no posted weight. This is closed off. It's closed off. So it would be nice to put some support under there, because obviously this is all a lot of load going here, and it's all being addressed with these two little plates, and looks like lag screws. They don't even look like they have through bolts. They're similar metals. And you got your rusting going on. You're a rusting, I called it, right? Here's your cross bracing. Look how they overlap. Over here, I think they did. Looks like a pretty cheesy fix. Yeah, I agree. It looks like they overlapped. Let me get this damn stone out of my shoe. Just give me a nice pleasure. Too much of pleasure. I only deserve that once a day. Let's do that. Oh, there's the date on that. I feel like there's testing my ass. All right. So there's your cross bracing on this. But they just use nails, so we can determine that with those nails only. That, which is a good thing for long term, is that there's no movement. So they didn't come into play all this time that that are the nails. They didn't succeed past the limits of the nail's ability to hold. Let's put it that way. Damn, that's pretty stone. Back here, look how this now crosses over. See the splice? Now, talking about the splice behind us and evaluating it. So it appears that this was the original. This archway appears to be original. I don't know if it was widened or not. It just seems like it'd be too much work. Although I found some weird, this recess. This is a weird recess, an odd recess. This right here, this whole little section in here. Very odd, this little shelf, and I'll show you on the other side. I think it's an indicator of something. Maybe they had some more weird bracing going across up to here. Let me see that. No, don't see anything like that. All right, and this is also appears to be kicking out. All of these members appear to be kicking outwards like that. Although if I look at the side of the structure, it appears pretty plumb. But this has an indication of going that way. Now, yep. So now what else am I going to show you about that? So now that I can stand on this column and get a nice little detail up here, we look at this thing and looking for clearances and compression. So it's only got so much contact. It's only got a little bit of contact. Let's get you around to the other side there. And if I fall in the water, I'm keeping the camera out of the water. And there's a little bit of contact. Now, is that our last member? Yeah, that's the last. Nope. Yeah, that's the last member where if it was a truss system where it was transferring the loads under driving it down this bottom cord. Yeah, there's none here. That's just floor joist. That's just walling. You see up there 2x4 and the sheathing. And then we got this little crippler here. So this crippler would count also as it was trying to transfer this little section here. Which ultimately, if it was a truss system, back up. I don't want to break my leg on these rocks. If it was a truss system more so than a arch system, well then look where the transfer loads would be. Right here before it's trying to make this into this last section. This last section, and these two aren't really tied together. Even this, what appears to be original Baltic system, tension. So it appears that they would be trying to transfer the loads onto here, the last one being tension. It's which would be an interesting concept. This is clearly what I was just trying to describe to you guys about compression. See the how compressive it is, how much it compressed in. So this is clearly under tension. This load from the deck is clearly going onto this member, pulling on the tension on this bar, which is then going back into the truss system in a notch. I believe I have to look at this side. I did not look at this side of the building, but putting load back on top of this arch, which then transfers the load back down into the abutment. So if you guys follow that, it appears the arch is more primary than the truss system. Truss system, I think it's a combination of both too, but the truss I think is more primary than, the arch is more primary than the truss. I don't know if I have to go past there again, but let's go up this side. I did not go up this side at all to look at that one member where I mentioned oh, wow, that's interesting. I didn't see that. I didn't walk this far. It turns. It's it thins out. I mean, that's down to inches. Oh, and it keeps on rolling around. Okay, I got you. So this was the approach at one time. Yeah, I think I will go back inside again. Oh, well, I'm top now. I never got to go inside. 1860. Okay, now I can put that on the website. It's saying circa 1860. High and wide a load of hay. high and wide as a load of hay. I didn't get the height on it. Built by Ferdinand Wood. What kind of name is that, huh? Newtown Square Historical Preservation Society. So here's that last, what we were talking about. And that's a spider. And it appears he's not kicking, so I might be okay. Quickly, nothing's behind there, so I don't want to be a dumbass and put myself in my own trap. All right. So that's the abutment. You figure we're on it now, up to that decking. There's the arch, as you guys remember. So it's right about there, going under the abutment, and this last piece is just flying over, if you will. There's that compressive, right there, that compressive tension member that we saw below that married up. It's got a bevel to it. I don't see compression on the top of it crushing down, so it appears to be transferring the loads pretty evenly, but maybe at the bottom, back ass of it right here, where that nut is, that bolt, that's an interesting, maybe it's a stop to keep it from any horizontal movement or vertical, however you look at it. Downward movement towards the abutment, towards the bank. Now you can see what I mean about leaning, hopefully. Let me lean back a little bit. It's not the camera. This structure appears to be like leaning back and design. Leaning that way. That this is not plumb. That this is not plumb. And there's the arch. So as we look at the arch, you can see that this would be a compressive member, right? Where it came down, landed on it. And then we got this, let's go to this side. So we've got this is the wood we see notched through, the compressive member. And they tie in at one point through the dual, see the two arches? It's one on the front, one on the back side, notched and bolted to hold it together. And the next one up would be the tension one. You see the bar? Now that bar there would definitely be under compression, like a bending moment in the middle, as it's transferring the load back down to here, which is kind of running the load back around, isn't it? So it puts this back under. This is why I'm saying the archway is more important. So imagine if this is under tension, it's transferring the load, some of it in a nail, if you will, and kind of push that other one out of the way as the load forces are going downward, kind of push that one outwards towards that direction because of the way it's the orientation of it. But the load's pulling down. As it's pulling down, most of the force is coming down back to here, which puts it back in the bottom of the compressive zone. So it's a roundabout small circle right here, but it's all coming back to the arch. Because if you do this circle, if you put a load here on the deck, let's put the load here. So put a load here pushing down. As it's pushing down, of course, it's now grabbing all of this, pushing that down, pulling that down, putting it under tension, compressing this member here, this member here, which pushes the force back to here. This is already under compression. So you can imagine, so it's circling back around the wagons. Yeah, it's back under the bridge, remember? If I don't leave it. Back under the bridge, I got to go to the other side. No, I clearly see that let's show you this. You can clearly see that if you look at the member being, if that 2x4 in the back, I'm calling it 2x4, it's probably more like a real 2x3 or 4. You can see if it's plumb, you can see that the vertical, I guess the approach vertical, this is the approach we're on, it's going in a backwards orientation. So it's not by accident. I mean, that's not an accident, and that's not falling backwards. And you see that there's no disconnect there at the top. There's nothing going on, torquing or twisting. That this is all part of the design. Let me zoom out. Let me zoom out. Come on, zoom, work with me. Okay, try that again. All right. So now we see that, did it zoom all the way? I don't know. Okay. So it was designed that way, and you can see the concrete at the bottom, and you can see what appears to be a patch or a half-lap splice with the galvanized bolts. Yeah, because we look on this side and we don't see that. We look up, we see a patch in there at one point with some splice. So this appeared to been an issue, bone of contention for this structure, the design, this one member there. As you see, the interior members appear not, or I do not notice any other splicing like that. And you can see like a roof addition, if you will. Let's come here. You can see like a roof addition. And I'm saying that because of those bolt design aren't similar to what the other bolts were that the height might have been added to in the past. Beautiful stuff. There's the deck boards. And I do find it fascinating, this leaning out, if you will. Maybe it was the addition that did it, and they needed it. You know, this whole thing. Let me come down here. And I know we have distortion on my camera, but the camera, I think, is, I'm looking at both of them together. The camera's probably showing it at least distorted than what it is. And again, that's that leaning out motion, leaning out effect. But here's the but part. Those truss, the arch rather, appear to be plumb. So it's like the wall torqued out on left and right. Here's the kicker, though. If it torqued out left and right and it was built plumb, then we should see movement at the top of these. We should see the movement as it elongated. But we don't see that with these are ankle braces they put in here. All braces seem to be in place. All the, you know, within their tolerance of bend. I mean, look at that one. It's got some clearance on top of it. It's terrible, in fact. But this is, let's come over here. This appears to be in place. That one appears to be notched even. That one is a good hitter or something here. This notched one, I'm looking at the other side. Oh yeah. So this is notched too. I didn't notice the notch till now. Now we see the notches. So that was the original thing. So now we're going to get the extension. So now this might explain some of the bottom. Yeah, 5 degrees. Yeah, going good. So maybe this is an extension of height here. How did you get the wood into an arch shape? Bandsaw, feed down the tree, steam straight. It's patented, so you can find it, William. I don't know specifically how he did this design, how he did this. Patented. So you can pull up his patent and find it. They did do a lot of bending, steaming, as you said, steam bending. And if I'm looking at their splices, let's see, zoom in for you. I know it's grainy, but I'm going to run the member. As we run the member, looking at the bottom side, not the face, because you're going to see the bottom more clearly if you're going to find a splice. And now let's look at the top. And I don't see any splices save one, which is right about here. See that right where the bolt is, ironically? See that? That appears to be a splice. And looking on this side, wait, gosh, it's grainy. That's grainy. So zooming out, just so you guys know, my camera is 40%. Let me see if I can turn down this. So it's going to tap out soon. I had too much light on it. Backing out on this brick. Oh, we got a National Register of Historic Place, Washington Card 1860. This property has been placed on blah, blah, blah. Okay, and there's a little fire drill thing. Man, I lost some flesh on one of these recently off my leg, crossing over the guardrail. Wet, slippery. So that appears to be plumb. I mean, not, you know, it appears to be plumb, not leaning out as much, etc. Now, you heard me about the addition thing, and if you look at the top, no more clapboards at the top. Clearly could help for air, lack of ballooning, so you don't lift it up like a damn floater or something, or trailer. Let me scroll on down here. Somebody said something. Am I going back under? All right, I'm under. Come on, can't fit between these. Yeah, Blondie, I have a drone. I'll throw the drone in there, but I can't do a drone video in this, so I'll probably just load the drone video up separate and just call, and we'll get 4K. Hopefully the lighting will be good. All right, back into the cold ass water. And looking at that splice. So we had a splice down here somewhere in the arch. Yeah, I'm hardcore, right? Hard materials. There's a splice there. Let's go around the side of it. Let's zoom in. Great, zoom in. So there's your arch here. And I know it's grainy. Give me a second. I'll zoom out, but I'll give you a good detail on that arch. And it doesn't even look like it's touching, which is amazing. So that means that, you know, like if it's not touching, it's not under compression, right? So this one might be taking all the load, which would also explain. Because you make one longer than the other. You make one longer than the other, or you don't make them contact everything equally, well, you're going to have one taking up the load opposed to the other. And that could give you this turning or torquing moment to push it outwards. But I don't see the stretch on the top of the structure where it's bending out. That one's, I guess it all happened when they did the extension of this bridge, what appears to be an extension. And again, right here, this is just, doesn't make sense for the structure you know, I'm leaning that the abutment was right where we are. That this was all the abutment. And this, I'm not sure about. I mean, this, I'm not leaning towards that. I take it back. I just can't imagine them doing all this work to get another 2 feet on this side and that side. For what reason? I don't get it. I don't get the this repair. It's shabby, to say the least. And then we've got the tension members again. There's your bolts, you guys. Tension. And now we talked about the compression. Right. Where I was saying it was on this side where I said that the load would come back around. Well, here's the bar. That's that bar that's under tension. Here's the floorboard of the floor beam. So as you put load on here, call it whatever load you want, it then transfers over to this floor beam, pushing downwards, right? Pushing downwards. But just the force of this is bending this bottom cord to resist the force of bending the bottom cord, because the force is here and it's now transferred onto this guy here. To resist that downward force, it then has a bar in it with this plate and this hunk of wood. Pull the archways on top with this tension bar, if you will, on top of the archway. So as you try to push down, you're pushing on the arch, if you can follow that now. If you push on the arch, well, you're putting the loads back out to here again, back to the foundation. And that's all the way down. That's what this intent is, what it's doing. Now it's sharing the load a little bit on each side as you walk with your hay cart, as it said, hay cart and whatever cart, the hay cart and the other member. I'm guessing they had rot where the trusses met the abutment and some point supported the bridge from the bottom where you were now fixed where you were now the rot. Yeah, that one's just an odd dump. They've definitely been here a few times. You see the I-beams, these two I-beams reinforcing this whole structure, reinforcing the stringers. And again, we don't have any movement on these cross bracing, which is awesome. So it shows that the bridge is pretty stable laterally or crosswise, right? Cross-sectional wise. Here's your bolt system. I'm coming out. So here's your bolt system. And that's the original bolt system. Beautiful stuff, compressive. And you got a semi-notch there. And somebody asked me about milling. So we can sort of look at their milling now. I mean, it looks pretty damn chiseled and clean. I mean, this is beautiful stuff. If that was a saw, a hand saw, you'd see like an overcut, a kerf cut into the wood. Your kerf cuts from your blades. I don't even see kerf cuts. It's some really, take your time, right? And again, this is not even taking on much compression. It's not compressing there from this side. And same thing here. Pencil line. Nope, that's the cut. And no curve cuts even in there. And the accuracy was just so, you just, whatever. Maybe that's my torque. Let me look at this. This much meat left on this side, this much. And down here, my meat's inconsistent. There we go. Now I'm doing that bending. Now I can come up with that leaning, because now we've got maybe an inch and an eighth. And then we come down here, we've got 2 inches. And as we scroll down to this guy, we're back to whatever it may be. That's the outside. I'm basing that now looking at the notch. The notch alone, you guys can't see it. There we go. they probably only notched off. Now I'm going to look at the knots that they notched off on the left side, left viewing side. And I'm saying they moved maybe 1.5 inches. Oh. On this one, frick, can't see it yet. Hold on. Same thing. Friggin' perfect. So much for that. And we got about 1.5 inches. So now I'm going to have to nix that, thinking I just don't get the leaning. I don't get the leaning on it. I'm wrapping this up soon as we work. Okay, how about that? You guys see that leaning? You see that direction? And I don't think it's accidental. Not one bit. I think it's purposeful. I don't think the whole structure racked that way. I think it's designed that way, which would give you that FIU bridge approach. You know, where they have the leaning compressive members leaning backwards in a way. All right, stepping out of the water and grabbing my laser. And there's your other repairs down here on this end. Plates. Consistent with the right at the same, pretty much the same location. But now we come over here and I found it on that side, but not on this side. Except for we have a splice on there. But then they resolved it with this repair here. Now this another odd thing I said, the shelf, it's beveled. Let me show you. So it wasn't by accident. It's a beveled shelf. What was the intent of that? And remember the other side had that too, but not as clear, not as defined as this. Very, very interesting. Well, I'm going to take this video because I don't know what else to say. And I want to just keep this video as is without editing or blocking it. I just want to keep it so it can stay up. Now here's your repair. I think I've talked about that already. There's your tension member. Tension, compression, tension. All of it going back into the arch. Tell you what I'll do. I'll give you a shot of the arch as I walk on out. As I walk on out, I'll give you another shot of the arch from the other side. This bar is odd duck. It's on the other side of Bridge too. We got here. Got a little rain. It says that shelf will be from when they poured. Well, remember 1860. They're going to do some little dry stone stuff. But that shelf has also got a bevel in it that no one would create by mistake. That bevel is what I was. That bevel at the top part. If you back up the video, you can see what I'm referring to. Okay, there's your arch again. There's your compressive members. Now take note of this one compared to the other side. That this is the same. Will be the version of that where it was compressive. Let me get my finger in here. Going down, and I said that the load would sort of push that top member outwards. Look what they did here. They have a block behind that compressive member. Ultimately, the load just staying right there now and going down this way, back into the abutment, pretty much almost there. Not going fully up at that point because the compressive or tension is creating from the load being, zooming out. Zoom out, baby. So the load is here. Let's put it right there. The load is there. It's pushing downwards. It's creating tension in that bar, trying to expand, right? But it can't do that because the bar will stay together. But that tension, since it's trying to do that, will transfer load to the top of this arch. Let's get there. So it's transferring load to the top of the arch via this setup here. The post and the connection, come on. And the connection with that blocking. So it's like one-to-one there. It's like real direct. Back to the arch and back down. It would be nice if you could actually put meters on it and figure it out, but you can't. Some of it you're going to have to theorize. And as the computer models say of this bridge, they think the computer models say it's more truss system and the arch is secondary. You know, you guys make your decision on it based on all that data I gave you. Imagine if you pulled out the entire arch. I think this system's going to the ground. And you pull out the truss system, and I think the system you can't pull it all out. You got to leave these in, supporting the deck boards, the deck beams. So it's dependent on it at that respect. And if you can imagine, you could probably cut the top of the son of a gun off pretty good. probably chop off, if you secure everything, just thread it, just cut it, the entire top of this archway off and throw it in the trash. I don't think there's any, you probably have to put some blocking between it here, here, blocking across. The arch will still be under compression, it'll still be doing good. All right, any guys want to see anything else here before I shut this down? There's that. There's that side. There are the little windows. Ah, come on, baby. Was the bridge really? Yeah, it was originally built here. That's what it says. The shelf will be from, yeah. So, and then we have it here. We have the same orientation of these approach, I'm calling them approach verticals. I will fly the drone in there, but it won't make this video, right? Another one. I'll fly it in there. Hey, B. Be gone. Be gone, B. I got nothing to do with you. So, oh, thanks, David. Thanks for watching. So this is, we back, little lady. No, I'm not DJI. If you've got one on video, they got a privacy problem. So, ANAFI, ANAFI. It's a French company. Why French? Because they allow you to keep your privacy on your. So right here, they won't ship. They don't need my location. They need to locate location when you're running the thing because you need to get back, fly home. But you can press privacy where you do not have to share all your data. So where I fly. It doesn't share with the Chinese government. Literally, I talked to DJI and their app and everything else that did all this craziness on it. It goes back to the Chinese government, and they refuse to let them change any settings where you cannot fly it. Problem with that is that app also gives permission inside your phones. You know, your contacts and everything else. Screw that. I'm not sharing all that data just to fly a drone. I don't do that. So I got the Parrot, the Parrot company, and they let you keep your privacy. You can share it or don't share it. They don't have an interest in that. So we got some visitors. There's some lady across the creek there walking over. Yeah, I use a blonde. I use a well, I don't know how effective it is. It's sort of a Truss system. Truss, not Truss. TRSUT. A system that I use a firewall. So anything wants to send anything out, it's got to go through me first. Now Google has an interest in not sharing the data really, because they want to be the guardian of it, so they can sell it. So Google, you know, you don't have a choice. But anyway, disgusting really. But what can you do exactly? Yeah. So now look at this. We look at the seams here. Everything's immaculate. You know, there's nothing breaking apart. Even though I said we had some leaning, now it appears it's plumb. It actually got a little orientation inward maybe from kicking out the bottom just a touch, but that might be, yeah, that's wood. So no, I don't, that's a very intriguing setup. Now this one, as I look down the side here, it's got a bow into it going into the side of this structure. The siding, we can say that they didn't use a water level back then. They definitely have laser, but it's got, wave into it. And I don't even know if they've ever taken the siding off, obviously. They probably did when they did the extension. Obviously, that was stupid on my part. So they probably had it off and then put it back on. So, yeah, I probably won't do that. But look, here's your bottom view. Bottom view pretty good. And what's nice, though, is interesting, rather, is that the abutments seem to be pretty level. They figured all this out, obviously, with water levels. And if you guys know what a water level is, you just, some type of, anything to get a water level. Tubes. So 1860, you just needed some pipe or anything to come up with level. You can also use a, literally level a pipe and look through a pipe. And since it's so close, say, 80 feet, you'd be able to nail that a little bit. All right, so there you go. Anything else here? The good, the old water tubes, yeah. So this is this road. This is where She blows. It's Crumb Creek. It's where they keep the crumbs. And she went down into the creek. All right, so I don't have to change this video or do anything weird to it, like edit it. I'm gonna disconnect. You guys can evaluate it later, and if you want to, pause it. So thanks for watching. Thanks for being here. And I hope you guys like it. If you can tell me you like it, the content like this, the live video, I mean, down in the comments, that would really encourage me to know which way to go. Crumb is the name of the troll that lived under it. Oh, I'm going to have a piece of crumb cake. Oh, shucks. I wish you wouldn't have said that. That sounded good, actually. Damn it. Damn it. Crumb cake. Visualize it. William, here. So this is it, just backing her up. It's nice people come to see it. We heard a couple people and then saw those two. Thanks, Blaine. Yeah, thanks. I'll do a couple more of them then. See, too bad I can't tie the drone directly into a video. That's takes a minute. Thanks for the thumbs up. I just saw a couple thumbs up pop up. I'll do the these are nice, you know. I like they change up. The steel structures, I don't know how boring they are. I'll get boring you guys find them or not, but I still look at them, like to see the abutments and the transfer the loads. I'm all about loads, you know, structural engineering wise, all about transferring loads. All right, so 52 minutes, 38 seconds. And when I press cancel, it's just rude. It just sort of hangs up on all you guys. Take care. Love you all.